Okay, so today we're going to talk about the first major topic in Calc 2 called differential equations. And a differential equation you actually solved in Calculus 1 a little bit. For a differential equation, what you have for your problem is you have either y prime or f prime of x or dy over dx or ds over dt, which are all derivatives. So you're given a derivative and you want to find, when it says solve a differential equation, you want to find y. So if you have y prime, you're looking for y. If you have f prime of x, you're looking for f of x. If you have dy over dx, you're looking for y. If you have ds over dt, you're looking for s of t. In other words, you're given a derivative and you're asked to find the function that has that derivative. Where did this derivative come from? It's a backwards derivative. The action that's required is to solve a differential equation. You'll either be finding an antiderivative or evaluating an integral. Now, you may be asked to find one of two things. These are vocabulary terms that you have to be able to decipher as you're reading the directions. You may be asked to find a general solution or a particular solution. A general solution will always have plus c. I don't know if you remember when we took antiderivatives or evaluated integrals, a general answer we always included the plus c. That took care of the derivative of numbers, which was 0. A particular solution will always give you what we call initial condition. In other words, they'll tell you something about the function y. So they'll give you the derivative and they'll say, we know this about the derivative. They'll give you an initial condition. And that allows you to find c. So if you're asked to find a particular solution, you'll be finding an antiderivative and then figuring out what exactly that constant is, or a general solution, which you just put plus c at the end of the answer. So we're going to start with some exercises to understand the format of these problems. So really we're not going to be finding antiderivatives yet. We're going to be verifying or matching a differential equation with its solution by finding derivatives. So we have some example problems here. The first thing we're going to do is we'll probably just right now in this first little clip is to verify these two solutions for problems A and B. We are given the solution, in other words, the solution is y equals c times e to the 4x. And the differential equation is y prime equals 4y. Well, instead of finding an antiderivative, we just want to verify that this has this for a derivative. Or if this were our differential equation, the antiderivative, the general solution, would be this. So in other words, if we were solving, this was our differential equation, we were asked to solve this differential equation and find the general solution, this is what it would be. So here's how we start to work out problem A. First thing we're going to do, we're going to start with the solution. We are working forwards this time and just doing a verification process. So what we're doing here is we're going to find the derivative. That's the first thing we're going to do, find the derivative of y. So we're always starting in the solution with the solution here in these first problems. So we're going to start with y equals c e to the 4x, and some of you may look at this and think, oh my gosh, that's c, what is it? Well, c is a constant, remember, it would be a number. So remember, when you're solving a differential equation and you take an antiderivative, you're going to have a plus c, and you might be saying, well, this is not plus c. You'll see how this happens very shortly. I'm just going to take the derivative of this. So this being a number like 2, it's not really going to affect my derivative. So the derivative of e to the u is e to the u times u prime. The derivative of 4 is 4x is 4. So 4 times c would just be 4c. So this is my y prime. So I had my differential equation. The solution, they say, is this. I'm just trying to verify this by starting with this and taking the derivative to see if it matches this. Well, right now I would say, nope, there is no way that this matches this. Okay, well, maybe it does. 4 Well, let's see. See this part of my y prime? Doesn't that match y? Isn't that y? Y? C e to the 4x, c e to the 4x, that's y. So couldn't I just replace that whole thing with y? So I could say y prime is 4y, which in that case it does match. So yes, I have verified it. It works out. All right, so now we're going to do the same thing with problem B. We're going to start with this, and we're going to take its derivative. Oops, that should be a y squared. And we're just going to take its derivative. Now this is going to be what we call implicit differentiation. In other words, we take the derivative of everything on both sides, starting from left to right, and the derivative of x squared is 2x, plus the derivative of y squared, well, the derivative of y squared is 2y times dy over dx, because we have to treat it like the chain rule. Y is a function of x that we don't know. And the derivative of c times y, well, the derivative of like 4y, a number times y, would be that number times dy over dx. Okay, so I'm trying to verify that this, if I take its derivative, is going to look like this. All right, so let's see if it does right now. This definitely does not look like this right here. But I notice that these are the same, and these are the same, so is that the same as that? Y prime dy over dx? Yep, same thing. Equals c times y prime. So yes, just by taking the derivative, very simple, I verified that they look the same. All right, let's throw one more in there. I think we've got a little bit of time to do one more example. So example C, let's throw in a sine and cosine example. Let me get rid of this. Okay, so we've got one more example, and I'll just flip this over here. So I want to verify that if I take this derivative, that it looks just like this. Okay, now what do I notice over here that's different? I notice this has a y double prime. Okay, well, let's see what happens. Let's just take the derivative of this. So the derivative of y is y prime. And the derivative of c1 cosine x, c1 is a number like 7. Okay, so c1 is just it's called constant number 1. So the derivative of a number times cosine of x, the derivative of cosine is negative sine, would be negative c1 sine of x. Okay, now the derivative of c2 sine of x is positive c2 cosine of x. All right. So does this look like that at all? Well, not so far as I can see, because the derivative, this is the derivative, this isn't even a derivative. This is saying this is a differential equation. If I worked my way backwards from here to here, you know, this would be the function. Okay, well, here's what I have to consider is that this differential equation has a y prime. So what I would have to do is I would take the antiderivative once and then twice. So I'm probably going to need to find the second derivative here. So the second derivative of negative c1 of the y equals c1 cosine of x plus c2 sine of x, well, the derivative is the derivative of the first derivative, that's the second derivative. So the derivative of negative c1 sine of x would be negative c1 cosine of x, because the derivative of sine is cosine. The derivative of c2 cosine of x would be negative c2 sine of x. All right, so let's see if this, if I take its antiderivative twice, looks like that. Let's just verify that this is a okay format. So y prime prime, well, there's y prime prime. That would be negative c1 cosine of x minus c2 sine of x plus y, well, here's y right here, plus c1 cosine of x plus c2 sine of x. All right. So, what do we notice? What happens here? Don't those cancel out and give you 0? Okay. So what we've done by basically finding these two things, plugging y prime in there, y in there, these actually cancel out, and they give you 0, so that format does work. That's a different way of verifying. Alright, that'll take us to the end of this first video. These are 3 examples that should get you through a few problems from page 409. You should be able to do pretty easily problems 2 and 4.